In this video, we will learn some basics about fractals and see examples through sound and music. A fractal can be described as an object or quantity that displays self-similarity on all scales, and it can also be described with a recursive sequence where we feed the output back into the system. An example of the first description of a fractal is the Sierpinski Triangle. If we zoom in on the figure on the right, we can see versions of the images that precede it. We see that on all scales of magnification, the image looks the same. You can create the pattern by following from left to right and removing successive triangles, starting with one in the middle that takes us from the first to the second image. For an example of a fractal as a recursive sequence, consider the complex numbers defined by z sub n plus 1 equals z sub n squared plus c, where c is a constant and z sub 0 is the seed that starts the sequence. For some values of c and z0, the terms in this sequence grow quite large. For example, if we choose c equals 0 and z0 equal 2, the sequence we get is 2, 4, 16, 256, 65,536, etc. Or if we choose c equal 1 and z sub 0 equals 0, the sequence we get is 0, 1, 2, 5, 26, 677, etc. After just a few terms in either case, we can see the terms in this sequence can grow quite quickly. In these cases, it is said the orbit of z sub n tends to infinity. A specific example of this sequence is the Mandelbrot set, which is the set of complex numbers c for which the orbit of the seed z sub 0 equals 0 does not tend to infinity. For example, if we choose c equals 0, then the sequence is just 0, 0, 0, etc. And if we choose c equal negative 1, the sequence is 0, negative 1, 0, negative 1, etc. In both of these examples, we can see the pattern repeating the same values. Some really fascinating images of the Mandelbrot set can be made by using non-real complex numbers and interpreting the sequence of terms as coordinates in the plane. In the realm of music, there are examples of the description of a fractal as a recursive sequence where the output is fed back into the system. The simplest example of this is a tape delay system. In this system, an initial sound is recorded onto tape in one tape machine. The output of this first machine is fed into a second tape machine, where it is played back after the initial sound at a delayed time interval. The playback of the second tape machine is fed back into the first machine, where it is recorded and heard, and the process repeats itself. This sort of system has been used in many recordings. Here's an audio example. The loop idea created with tape delay can also be seen with repeated themes in music. Modern popular music sees these repeated themes in what are called riffs in rock music and loops in pop music. There are also musical examples of fractals that demonstrate the idea of self-similarity at all scales. To see this, we'll consider the Morse-Thue sequence, which involves writing the non-negative numbers in binary. If we count the number of ones we see in the sequence of binary numbers, we get the following sequence: 0, 1, 1, 2, 1, 2, 2, 3, and if we continue the pattern, we get the following sequence. What is interesting about this pattern is if we remove every other term, starting with the second term, we get the same sequence. If we assign numbers to notes in a scale, we can get melodies. Furthermore, if we relate the idea of removing terms to different subdivisions of the measure, we can get interesting countermelodies. For example, I've assigned notes to the sequence numbers in the following way. 0 is the note A, 1 is the note D, 2 is the note E, 3 is the note F, 4 is the note C, 5 is the note F sharp, and 6 is the note C sharp. What I'm going to play is a 4-measure sequence that loops. But as I play the loop, every 4 measures a new instrument will come in. The low notes only get through the first 8 notes in the sequence that we saw. The brass sound gets through the first 16. The strings get through the first 32, and the fastest part gets through the first 64 notes. The ideas we've seen with fractals can inspire starting points for interesting compositions, and just as fractal images can be inspiring pieces of art, so can fractal music.